Assalamualaikum and hi. My name is Nur Adriana Damia binti Hasnizam and my matrix number is 228586. And this is my video for assignment number 1, which is to set up the X86 programming environment. So as you can see here, I have already opened up the SASM and loaded the average for the ASM file given by Dr. Tarunizam. So now, first and foremost, I am going to build the program to make sure that there are no errors while we execute the program. So we're just going to press build this. We're going to, so as you can see here, it stated that it has been built successfully. So now we can start to debug the program. So we're just going to press debug. As you can see here, the debug has already started as it stated here. So now I'm going to show you the memory window and also the registers window. So first we are going to add two variables, which is first going to add data variable. For this part we're going to change it into hex. For this part we're going to change it into W, and array size we're going to type in 4 since we needed 4 values to calculate their averages. Next up we're going to insert result. So for this part, we're going to choose hex. This part, going to choose W. And the array size, going to type in 1 because there's only one result, which is the average that we're going to count. So now, we can see here the registers window, such as EAX, ECX, EDX, and also ESI. I will focus more on those registers as we go through the program. So now, I'm just going to use the debug and this step over to execute the instructions. So now, as you can see here, the green arrow is already on the first line, which indicates that it is ready to be executed. Now I'm going to click step over. Let's click step over, and now we are on the first line of the instruction, which is sub EAX EAX, which functions to clear the register AX. So as you can see here, when I click step over to the next line, the register EAX becomes 0 to clear the accumulator before we conduct any calculations. So moving on to the next line, which is MOV ECX 0x04, which functions to set the counter to 4. So now, as you can see, when I click step over again to the next line, the register ECX have become 4. So this value will be used as the loop counter for the 4 elements in the array. So if you take a look back at the memory window, you can see that there are 4 values there. So now, moving on to the next line, which is MOV ESI 0x08, which functions to set the offset to 8. So when I click step over to the next line, step over, the ESI register is set to 8, and this register will then be used as an offset to access the elements in the array. Now we are going to move to the AW loop. So in this loop, we are going to sum all of the arrays in this loop. So now I'm going to click step over, and we are going to observe the changes in the registers and also the memory. So the first instruction in the loop is DEC ESI, which helps to decrease ESI by 1. So as what we have go through just now, the original value set at the ESI register is 8. So when I click step over, the program decreases the ESI by 1, and now the current value of ESI changes from 8 to 7 due to the decrement by 1. Now, the second line is also DEC ESI, which is decrement SI by 1. The ESI value decreases by another 1, which then changes it from 7 to 6 due to the decrement executed by this program. I click now. I have already pressed the click over, and now the ESI register have turned into 6 due to the decrement of SI by 1. And now for the next line is the add AXDS data plus ESI, which functions to add number to register AX. So when I click step over again, we can see that the value from the array data at the address data plus ESI is added into EAX here. So you can see that before this whole loop is executed, the EAX value is 0. Now, since the data has been added into EAX, this means that we are accumulating the sum of the arrays. So moving on to the next line, which is loop AW, which functions to loop to label AW and also to keep looping until CX equals to 0. So which means that this loop will keep on repeating until the value of CX in here turns into 0. So now I'm just going to click step over. And as you can see, the ECX has turned into 3. So we're just going to continue the loop. Step over, step over, step over. And now when I press another step over, you can see that the ECX has turned into 2. So each time I click step over, each loop adds another element from data into EAX. And then the CX also decreases from 4 to 0. So as you can see here, the CX has turned into 1. I'm going to click step over, step over, step over, and another step over. And now, after 4 iterations, AX contains the sum of all 4 elements. And once the CX value is equal to 0, the program automatically exits the loop to carry out another set of instructions, which is to calculate the average of the 4 elements. So now the first instruction that you can see here is sub EDX, which functions to clear the DX register here. As you can see here, before I click step over, the EDX has value in here. So now I click step over. Well, as you can see, the EDX has turned into 0. As I said before, when we want to calculate something, the value in the register must be 0. So moving on to the next line, which is MOVCX0x04, which sets the divider to 4 data. So when I click step over, the ECX becomes 4, which is the number of elements in the array and the divisor that we wanted. Next up is the IVCX, which functions to divide AX with CX. So now when I click step over, you can see here that the EAX is now contains the average of the 4 numbers after we divided it by 4. Now we have reached the MOVDS result line, which is the location that the result is going to be stored into, and also the location is pointed by result. So now before I click the step over, you can see that the result in this memory window remains 0. So now when I click step over, you can see that the result in the memory window changes from 0 to 2800. So for the bonus task, I'm going to print out the result into the output window here. So now I am using the print hex macro command, which is print hex for result and print, and also I included the include io.inc for me to print the result in the output window. So now when I click step over, here you go. You can see that the result from the memory window is already been printed in the output windows here. So that's all for this video. Thank you so much.